Are you ready for our biggest mechanism of the semester? The biggest one is this bottom one. The top one is actually one of our simplest mechanisms. It's called hydroboration, good name. Adding a hydrogen on one side. And I just want to remind you, electronegativities, En, H, 2.1, B, 2.0. Which one's more electronegative? The more electric. Yeah, you're right. The H, sorry. She was right all along. Yeah, we're just not used to saying it. That's why I had to pause. Because my brain is programmed, if I hear H is more electronegative, I'm just programmed to say, no, you're wrong. She's not. She's right. Here's an exception, right? You don't see H bonded to a less electronegative element very often. And when you do, it's often called something like hydride. Like here, sodium borohydride, when it's an anion here. It's really the equivalent of an H minus, isn't it? Ide. That's a different boron entirely. That's the ionic boron. This is a neutral boron. This one loves alkenes. The other one loves the mercury. They have different behaviors. Now, the cool thing about this mechanism is when you make a fourth bond to B, what charge does B develop when it gets a fourth bond? Negative, that's right. Because it's a group 3 element. Normally it has 3 electrons that it owns. If you have 4 bonds, that's like sharing 4 electrons. That's more than 3. Yeah, B would be negative. So what you did with this one arrow is make a B negative, right? And carbon is attached to this B, that's negative. And carbon's talking to this B saying, you get to have more bonds than me when I have an electronegativity 0.5 higher than you? No, sirree, not on my watch. I want my electrons now. Carbon's very verbose in this discussion, yes. What happens is hydrogen, one of those hydrogens says, I'm hearing this carbon make a lot of noise next door about how he needs electrons more than you, Mr. Boron, and I'm jumping ship. I'm going over to carbon right now. And which carbon does it want to go to? The one that spends more time with a plus charge? Because it's bringing its electrons with it. H is going to bring a pair of electrons with it. It's more attracted to the carbon that spends more time with a plus charge. Which of those 2 carbons? Tertiary or, yeah, second. The answer is tertiary. She got it. And did you see that both those arrows are happening at the same time? Arrows at the same time give, and I'm just going to point and circle or highlight. Same time gives sin. And you just think about it. Think about it. Here's a ring. It's kind of flat-ish, right? In my hand. Can you have the BH3 be both here on top and here on the bottom at the same time? No, you can't be in 2 places at once. No atom can be, no people can be, nothing. So you're either coming from the top or you're coming from the bottom. And if you come from the top, you get 2 wedges. If you come from the bottom, you get 2 dashes. You get a 50-50 mixture of 2 products. I only showed one of them. You never have to show me more than one. Okay? Just one. All right? And that doesn't give the result highlighted here. It gives the result where there's still 2 H's on the boron, right? I'm going to write an aside. It's not part of your quiz. It's an aside over here in this little box area here. Can you squeeze it in? Those arrows made this. We got H2. No, in fact, I'm not going to do it that way. I'm going to do it this way. H, B, H attached to the ring. Okay? You've got that. And then another double pi bond. And I guess it looks, oh, the double bond's not in the 6, it's in the 5, right? And the 6 is glued to it. And why are we attacking the B and not the H again? Remind me. More electronegative. And then that produces int. And third time, this is the first, second, third gives you got your H and you got your BR2. You notice the name of R is this group I drew? I hope. Yeah, you've got three R groups on the boron. But Dr. Whitaker, I only see 2 R groups on the boron. That third one is drawn. There it is. There's 3 identical groups on R because this reaction happened 3 times, and you can't even stop it from happening only the first time because this boron is more reactive than the original. Why is this boron with a carbon here more reactive than this boron that had an H up there? Carbon is more electronegative, which means the boron is becoming more positive, which attracts the alkene pi electrons even faster. Think about it. You just converted to a boron that's more electrophilic, didn't you? Because carbon's pulling on these electrons. Okay, and it happens 3 times. I'm not showing all the intermediates. You never have to show me even twice. You show me 1 time, like I did up here. But you do know in your mind that all 3 of the H's react and 3 alkenes are involved. There's the alkene number 1, alkene number 2, and I didn't even show alkene number 3. Stoichiometry was 3 of these gets you 1 of these when you react 1 of these, right? And 3 of these and 3 of these give 3 alcohols and 1 of these. There you go. So the top mechanism, I know I talked a lot. It had 2 arrows in it, and that was it. The top mechanism. You didn't even have to draw any intermediates. You don't have to draw any of this. You go from here to what I draw here. On the test, I would have said like H2B, or on a test, this is what I most normally do. This makes you know you didn't have to do it 3 times. If I actually start with 2 of the R's already on there for you, then you're doing the 3rd one for me. That's how it ends up on every test. I've done 2 of them already. You show me the 3rd one. And that's what happened right there. These 2 arrows, you're done. So in reality, though, we start with the BH3 and it reacts 3 times. Okay, and this one, this is our biggest mechanism of the semester. And I'm going to say this boldly. It's one of the best done mechanisms year after year after year. Because I promised the students it will be on their tests. I give you breakdowns with memory tricks in probably 4 or 5 videos that exist already. This will be the 6th or 7th or 8th, right? There's certain patterns in the mechanism, and there's certain oscillations, like alternating between this state and this state, back and forth, back and forth. A lot of talk. You don't need any talk. Okay. 6th step. 1st and 6th, both acid base. So your first step and your last step are going to be acid base. I see a strong base, don't you? I think you should start there. I don't see a strong acid. Don't start there because you can't. There's no strong acid. So I'm going to use this base and react with the strongest acid proton around, which is the peroxide. If you had to give me a guess, you'd say, what, 16, like water? You wouldn't be that far off. 2 arrows, okay? Unfortunate choice of colors for my numbers there. I wonder if I can change that. Won't even lay on that. Forget it, that story's over. You're gonna get a peroxide ion. And it's gonna attack the most positive atom now that remains. Hydrogen was the most positive atom on peroxide. What's the second most positive atom on the screen right here? Boron. We're going to attack boron. We're going to make a 4th bond to boron, and this time we're not going to compensate. We're just going to make a 4th bond to boron. There's no carbon next door saying, give me those electrons. You just go ahead and attack that. R is already defined here. Feel free to use it as many times as you want. You got your hexane, cyclohexane, sorry. I'm not even going to show that H. I'm going to show B with 2 R groups. And the new thing is, and then you tell me one more thing I have to put on here so I don't lose a half point. Don't say the blue H. I don't need the blue H. But there's something on boron that wasn't on boron before because this boron has 4 bonds. No, boron would have to have 2 bonds to have a positive charge. It's an anion, yes. Remember, it being in group 3 is what messes students up with that formal charge calculation. If you got 4 bonds and you're in group 3, you're an anion. So please take note that boron started with no formal charge and now has a negative. It's going to, in the next step, I promise it'll be no formal charge again. And in the next step after that, I promise it will be negative again. And in the next step after that, it will be no formal charge to finish. So you went from a 0 to a -1, back up to a 0, to a -1, up to a 0, and tell me why this particular teacher likes that so much. The W. Your boron's doing a W with formal charge. 0, -1, 0, -1, 0. Got it? So we've only done the 0, -1. You got to get to a 0 and a -1 again, and then back to a 0, and you're done with formal charge. So it's just a pattern you got to keep track of. The coolest part in this reaction is what happens next. Boron with a minus charge has a lot of people upset right now. Oxygen in particular. Oxygen, you're 2.0, I'm at 3.5. Give me whatever you got. Oxygen here is saying, I'm going to break off one of those carbons because CO is a much stronger bond than CB, right? O makes much stronger bonds. And look what happened here. Oh, yes. Why are peroxides so reactive? Because when you have adjacent oxygens, then you have lone pairs on atoms adjacent to an atom with lone pairs. Lone pair repulsions make all those species reactive. Whether it's hydrogen peroxide or iodine, that's the purple stuff the doctor uses, right? They do not like being bonded to each other with adjacent atoms having lone pairs. You have solved that problem. You solved the formal charge on the less electronegative atom. We don't like a minus on a less electronegative atom. We're solving that too. and you're making hydroxide. If I put a meow, would that be cool? Up until now, it's a meow. Yeah, where the heck did the meow come from? Who says meow? A cat. No, not that cat. It's the only wrong cat he came up with. He said cat. Whenever I go meow, I'm talking catalyst. And catalyst. And you started with hydroxide in our very first step, right? I'll remind you 6 steps, right? First step, first step was here, acid base. We used hydroxide there. And step 2, just a OOH attack. Step 3, got our cat back. Hydroxide is back. But the cat is no more. Because in the next step, the cat is going to be a reactant and is never going to come back. So I might regret having said cat at all. All right, it took its bond. It used to be to B, now it's to the O, which was still bonded to the B with 2 R groups. I purposefully drew it like that so you know I didn't move any atoms on you. Except there's no CB bond, it's now a CO bond. And I'd rather have a negative on a oxygen than a negative on a B, right? That's one driving force. And the main driving force was that discussion about these guys. What was the main driving force? Getting rid of these, and these don't like each other. That's what I meant by this. Lone pair repulsion was the main driving force, getting rid of that bond. Now you don't have O with a lone pair bonded to another atom with a lone pair. It's gone. Okay, what patterns have I told you about so far? 1, first step, and 6th step are both acid base. We're not at 6 yet, so keep that in your back pocket. Charge for boron. Hey, its promise is being fulfilled, right? Started 0, then went to negative, and then it's 0 again, as promised, right? Good. Here's another promise. You've made an oxygen anion for the 2nd time. Do you agree? The first oxygen anion you made was here. What did you do with it? Because you're going to do the same thing again. You attacked the Bs. What do you think you're doing with hydroxide now? Attack the B. Nice. Attack the B. And that discussion's over because it's the 2 time. Okay? So next time you make an O minus, it's not doing anything special. Well, it's doing something else special. But it's number 6. If it's the number 6, what's it doing? Acid base. That's right. So your next O minus after did you make after this one? Acid base at the end. Oh, a lot of talk. We're at 4. When I didn't draw my small ring, and you guys are so nice, you didn't even mention it. Somebody would have. Okay. And we got my sideways hexagon. I'm working on it. Not too much of a fan. So we got our black bond to O. We got the old bond to B, which had 2 R groups on it. What else is on the B now? Hydroxide. Now, how many bonds does B have? 4. So what charge does B have? As promised. Next time, when you go back to neutral, your charge is over, right? There's only 2 tips on a W. 2 dips. Should be called a double V, right? It is in a lot of countries. Yeah, double V, French, that's how they say it, double V. In the German, they say it as a V, right? Double V, yeah. Well, if you write it like this, it's a W. We're getting into some silly stuff right now. I love the W, but in French it's double V, which is how a typewriter writes it, right? Yeah. Okay. We're not finished with the W until our next step. And here's the next step. You ready? This one. Basically, you're taking one of the bonds from B to O, and you're putting a new bond on there to O and getting rid of the old bond to O next. It's a trade. You made boron trade O's. That's what you did. Traded O's. And this is an O minus, but you're not going to attack B next time, right? Because step 6 is looming. Step 6 is the acid base. I did not draw that in the right spot. We've got O minus right here. It's green. And you've got R2, wow, B with an O. Draw that bond to H, please. Why do you think I drew that bond to H? It's because step 6 is what kind of reaction? Acid base. I need a proton and a base. You see both things? I see both things. And you're making an alcohol. Surprise? Look near the top of the screen on the left side. What functional group is that? Alcohol. It's called an anti-Markovnikov alcohol. What? How could it be called an anti-Markovnikov alcohol? It's the more electronegative O's on the left substituted carbon. But I thought the first reaction was Markovnikov. I didn't lie. And we're not done with 6 yet either. I'm coming back. Sorry, you got to bear with me. We'll be drawing the alcohol and this, and then a bunch of arrows to finish it off two more times. But up here, the more electronegative element ended up on the more substituted carbon. That was true. It was Markovnikov, the first reaction. H is more electronegative than B. That's what tricked a lot of us. And then we did some different chemistry. There's no alkene here, right? So it's not about alkene chemistry anymore. It's not about carbocations anymore. So it's a whole new ball game. We're just replacing the B with OH, if you look at it. That's the net result, isn't it? So we tricked the thing into being anti-Markovnikov at the end. Because alkenes don't do that. And then we got this. This is alcohol number 1. I got to draw the 5 soon. Also put the alcohol in the wrong spot. Is it green? R2BO8, O minus. Oh, we're done. We are done. Why did I draw any of those? I made a mess of your notes, I know. Why was that all not necessary? Because we already have those drawn right there, right? Just a big old arrow. And just if you're curious, you don't need this on your quiz at all. You repeat 1, 2, 3, 4, 5, and 6, and then you repeat them again. And you get B, O, 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 which is called borate, plus 2 more alcohols. ROH, right? And this is an aside. You don't need to do this on your any activities ever. You never do the same mechanism over and over. Okay? So at the end, you get 3 alcohols. Yeah. All anti-Markovnik. All good stuff. So for your journal, what do you do? What do you do for your journal? Nobody's copy paste. You mean copy by hand?
Yeah.
It's got to be by hand. Yeah, you could do that, but I really prefer if you go from the textbook. Now that we all have the textbook on, my goodness, people, we went a half semester without the textbook and nobody said anything. Professor, I didn't listen properly. Obviously, that you were having trouble accessing it. My apologies. I should have heard better than that.
I took my brother's textbook from 5 years.
See, he had a textbook. He had a friend or a brother. Yeah. Okay. Well, it proved something to me. That the new materials are adequate for getting through chemistry because you guys you weren't struggling.
Yeah.
I mean, it is a good tool to have. And a lot of people are a little older school and they like a textbook. They do. I'm one of those guys, you know? So I just want to, I don't know if I should do this. It's risky. Now you'll see my email. I sent you the chapters from my email, right? Okay. I'll just do a quick thing. Screen off. Don't forget to make me turn the screen back on. Yeah. Just want to show you one thing before I let you go. I already logged in, dude. When did I send it, you know? Saturday morning? Friday. What date was that, you know? Friday. It says Friday. Organic chemistry correction, software show. I'm not gonna find it, am I? Oh, it had chapters in it, right? CHAPTER, maybe. Ebook. Here are the links. Good. Oh, chapter 6 opens from my Google.
Yeah, you sent them through Google Drive.
2 of them.
Yeah.
There, I got it. Okay, here's what you do. 5, 4, 3, 2, 1. Hunt down the shadow boxes, people. There's a shadow box. You see it? You copy this, the title. You copy everything in the shadow box. Done. No mistakes. Don't miss any arrows. Okay? And you keep going to find more shadow boxes. There's another one for the same section. I mean, you could have, I don't care if you have multiple entries for the same section. It's still in section 6.1a here. You could do this shadow box instead of or in addition to. I need 1 minimum, okay? Textbook minimum is fine. Hey, there's 6.1b. Copy the shadow box. There's that's another version of 6.1b. Up to you. Carbocations. Sadly, no shadow box. I didn't put, I forgot. But you see the curved arrows? They're mechanisms if they have curved arrows in them. I think twice in the whole textbook this happened. I forgot the shadow box. That's a different kind of shadow box. Okay, but you see the curved arrows, you could copy all this. They look like the one we did in class too, right? Yeah. So if you already did those, it doesn't matter. But shadow box. Halogenation, we got shadows. Yeah. You can do this whole semester tonight. Yeah.
And is it the same box?
No, I haven't got, none of them are ready. You can't submit them tonight, but you can get them done. And scan them. Yeah. I haven't sent you chapter 7 yet. She's working on it. Something goofy happened. They can't even tell me because they don't know what happened. Something weird happened, people. This was not supposed to happen. The book disappearing. And I think it's because we're the little fish in the big sea. They don't make any money from us. So we're not a high priority. Okay. That's okay. We know we're important. You know what? That's all on video. Did I say anything inappropriate? Did you?
No.
Okay. What will be the title for the end part? How to do your journal for the whole semester? Okay. Oh, yeah.